28th question from projectile. And the question says that for a given speed u and for a same range r, there are two different maximum heights. And that has to be. That happens when the angle of launch is theta and 90 minus theta. The range would be same, and yes, the height and the time of flight would be different. But here we need to relate that r with h. Therefore, what will I have is something like this. R is u square sine 2 theta divided by g. Be it theta, be it 90 minus theta, in both the situation, r is the range. Now, let's calculate the maximum height. In the first, the maximum height is u square sine square theta divided by 2g, and in the second, that's going to be u square cos square theta divided by 2g. All right, now you multiply h1, h2 and bring it in terms of r. That's a very straightforward one. Option number 2 is going to be the correct option. Let's go to next question, question number 29. The penultimate question, question number 29, that's from thermodynamics. And see, this is also derived from second half of the first year syllabus. Well, if you have been following my video solution in this subject, you must have certainly seen with regard to JEE Main, there are 4 or 5 points where I particularly stress out. Like number 1, specific areas only for JEE Main, like semiconductor, principle of communication and other things. And the second half of the +1 syllabus, the experimental one, the modern physics, these are all the portions which need to be taken with great attention. Now let's see, it's a diatomic gas and it does 10 joule of work at isobaric expansion. And you need to calculate the heat in the same process. A very, very simple question, and it says 10 joule isobaric expansion is nR delta T. And we need to calculate the heat in the same thing. So that will be N Cp, which is 7R by 2 into delta T. Well, if this is 10, this has to be 35. And option number 2 is the correct option for 29th question. Time to go to the last question. Well, the final question, and it has been put from electromagnetic wave. Just in the previous discussion, I had said certain portion reserved for JEE mains only need to be taken with extra attention, and electromagnetic wave is such. You generally tend to get a question from that. There is an electromagnetic wave having frequency 23.9 gigahertz, and the wave is traveling in positive z direction. The peak value of electric field is given 60 volt per meter, and we need to calculate the magnetic field for this given condition. The question can be verbally solved here. In fact, even calculation is not required, because if the wave is traveling along positive z, it's only third option which satisfies positive z. So there's no requirement of calculation. Immediately you can do that. But still, just to justify, because this is a question asked in JEE mains, so let me try to speak 1 or 2 sentences about that. The electric field peak value has been given, so B peak would be E peak upon C. So from that you can calculate B peak. The frequency has been given. The frequency of electric field and that of magnetic field is exactly same. But here you need to specify in terms of omega. So omega will be 2 pi f. And if you want to find k, yes, k would be equals to omega by v. So by doing that, you can calculate even these values. But as regard to this question, there is no calculation required, because only one equation has the characteristic for traveling along positive z, which is option number 3. So option number 3 would be the final score of this over. Okay, with this, we've completed the discussion. If you were the one who appeared for this examination, I pray to Almighty for your wonderful, successful, and colorful result. If you are the one who is a future aspirant trying to prepare for upcoming JEE main examination, hope these discussions were very helpful. They were made precise considering the time slot, but yes, valuable insight, and wherever it was required, I made a point to discuss so that you can get an overview apart from solving the numerical. It's time to sign off. We will certainly be meeting through different platforms like the video solution of the entire courseware and other things. Till then, you take care of yourself. Thanks for watching. Bye-bye.